Hi there. I'm going to show you how to do a quadratic regression using Desmos. I'm getting some questions about that, and I know that the things that you look up might have been for the old calculators. There's references in the textbook that show how to use the calculators, but we're kind of using Desmos now. So let me open up a problem, just a basic problem, not necessarily a word problem, but just a problem that shows a data set. We're being asked to do a quadratic regression to fit the best curve we can through what points that those would show. So I'm also going to show how you can take a data set, at least from my math lab, and quickly copy it to your clipboard and then drop it into Desmos. So you don't have to actually type all the numbers in. If this doesn't work, of course, you will have to type the numbers in, but this is just something that's kind of nice. So when you click on the little option, the little box next to the table, one of the options is to copy to the clipboard. So when you do that, it opens up the data set and highlights it. If I go in here and right click and copy that, I have to do that in order to get it copied. Now I'm going to go to Desmos. So let me see if I can change my sharing screen over to Desmos. I'm going to stop sharing that. I'm going to share the Desmos screen, share that. Okay. If you go and click on the first line where you would normally add a table, instead of having to click the add a table feature here, like is what you would normally do, plus and then add a table and then type your numbers in, what you can do instead, at least this works on my computer, on a regular laptop. I don't know how we do it on devices like phones, but you click in there and then there's an old keyboard code for pasting something. I don't think the right click paste works, or at least it doesn't for me, but I can do Control V, which is also another way to paste. And if you do that, watch, Control V, it drops that scatter plot in there for you. It automatically registers which column is X and Y. And if you look over here to the right, it also shows they have readjusted the screen, the window on the graph that it's showing, so that we can see the points. And the points are in red because that's just the color it chose there for the Y1, X1 scatter plot. All right, so anyway, that's a really quick way to pick up some data from someplace else, drop it into Desmos with Control V. You highlight it and copy it. Go to Desmos, just do Control V, and it drops in the table and also puts the scatter plot in there in one step. It's kind of nice. Now, if it said create a scatter plot, that's all we'd have to do. But what it wants us to do is to do a regression with some kind of shape. They have specifically asked us in this problem for a quadratic regression. So that's what we're going to do. And if you look at the shape of the scatter plot, it looks like it's increasing a little bit slowly over the first couple of points and then a little bit steeper as you go on. So there is a little bit of concavity to this. It seems to be kind of curved downwards a little bit. So probably a spread out wide kind of quadratic, like the right hand side of a quadratic, would probably fit that better than trying to just shoot a straight line through it. So we're going to do a quadratic regression. So on the next line, I know I may have talked about this a little bit for linear, but there's certain things with regression that are different than just typing in a function. If I want to just type in a function or an equation and have it graph, I use the letter X and Y typically, and that's how it knows the input output. But if I wanted to use the data from a table like this, where each table's column is labeled as X1 and Y1, that means that those are values for data points, not generalized values for X and Y for an equation. So I have to remember for my quadratic regression or any kind of regression to, instead of just using X and Y, to use X1 and Y1. That tells the computer or Desmos where to go to find the data to produce this equation. So a quadratic model is normally looks like ax squared plus bx plus c. So I'm going to say ax1 squared plus bx1 plus c. And instead of having that being equal to the y value, it's going to equal y1. And so there's one other thing, but let me start typing. So I'll do y1. You just have to hit the 1 key and it will automatically put the subscript on it for you. And then instead of saying y1 equals that quadratic expression, because that's what I would do if I wanted it to just graph a smooth curve, I want it to do the curve through the regression using the data. So the regression command is, instead of equals, it's this little tilde sign, kind of like one of these curvy, like part of an equal sign, but an approximation, but just with a curve on it. That symbol on my keyboard, most keyboards that are like traditional keyboards, is to the left of the number 1 key in the top left-hand corner, and you have to hit Shift to get to it. So if I were to show you my keyboard, like, there's the 1, and then there's the tilde right there. All right, so I'm going to hit Shift tilde right there. That's how you tell it we're going to do a regression from the data that you have already typed in. If you don't already have data typed in and you try to do this, it's going to give you an error message. It doesn't know what to do or where to go look. Okay, so now I'm going to type in my quadratic equation. I'm going to use a, b, and c for the generalized coefficients that I want it to figure out. And then instead of x, I'm going to use x1 for the rest of the terms. So I'm going to do ax1, and then I need to square that. So I'm going to pop up my menu below there to get the squared symbol. And then plus bx1 instead of just x, and then plus c. All right, so as you're typing in, and it's doing the best it can to do the models with the information that you have. Now that I've done all 3 terms, I have a quadratic model, and you can see the green shape that graphed is using the most accurate calculated values for the a and the b and the c. The values that it uses to graph that green line that Desmos uses are even more detailed than the values that it's showing right down here, where it has A equals 99.78, B equals 2.01721, C equals negative 1.67857. All right, that's showing everything out to about 5 decimal places. Desmos actually remembers these values to a much greater level of detail, so many more decimal places than what it shows here. And that's important if we're going to use this model in some future homework problem to, say, do an estimate or a prediction about other values that we don't have in the data set. Or maybe you just want to make a prediction, see how well it estimates data that you already have in your data set to see if it's fairly close. But with the scatter plot, we can take a look at that and say, that's a pretty good fit right there. It seems to be fitting through all or most of the points. In fact, as I'm looking at the information here, it actually is, that data happens to be perfectly quadratic with no variation along the pattern. And the reason I know this, it doesn't ask for this in the homework, but the R squared statistic down here, if the R squared statistic equals 1, that means it's a perfect fit, that there wasn't any variation of the points where one point was a little high, maybe the next point's a little bit low for the quadratic model, but overall it fits the general trend. This means that those points actually were all on the same quadratic curve. If you have a fit where the points are not so perfectly lined up, but they still have that same general pattern and the quadratic still fits it pretty well, you'll have an R squared value that's close to 1, like 0.95 or 0.99 is a pretty good, very strong fit. Okay, so this one, since the R squared is exactly 1, it's a perfect fit. If the R squared is close to 1, like in the 0.9s and stuff, that means you've got a really good fit, but the data just doesn't perfectly line up. Anyway, so this is a perfect fit. Now, what I was saying earlier about how it remembers more decimal places, I'm just going to type the letter A on the next line so you can see what Desmos remembers for the letter A, because right now it's just displaying the 5 decimal places, but I'm going to hit A. No, I'm not. I'm going to go to the next line. There we are, in row 3. I'm going to hit A, and all right, it didn't remember that much more, but look at it. It has 6 decimal places, 7, 8, 1, 2, 5. So that's as far out as it was able to take it, or maybe this stuff is so perfectly lined up that it doesn't have these decimals that go on forever. So A, it actually is 1, 2, 5, and it has been rounded up to the display it gave us in the first part where it says 0.7813. Let me see what B is. Okay, so B is an example here. Look at how long that decimal is for part B. That means it actually remembered whatever that is, 12 decimal places. It only displayed the first 5 decimal places in the model when it returned the regression equation. But when you want to use these models to actually make a prediction, don't just use the 5 decimal places that is displayed at the end of the regression. You're going to go ahead and write your function, now a regular function where you do x and y instead of the x1 and y1. You're going to go ahead and use the generalized form A, B, and C when you write your model after you've done a regression so that you're having the most accurate computations possible. Okay, so so the basics of this are either enter your data set in as a table in Desmos, or in some cases you might get lucky and you can copy it out of a table somehow, and then you just, when you paste it using Control V into Desmos, it automatically builds the table and automatically builds the scatter plot. And then this part that I have here on line 2 is the most important thing. That's how you get the model, and we just can't do this kind of thing by hand usually. This was perfectly fit, so it would have been possible, but normally we're not able to completely get it as accurate without using a tool that does regression. Regression has lots of formulas, and it's a lot more than what we're going to do in this class. So you have a regression feature like we have in Desmos, and then that gives us the A, B, and C values. Those are the coefficients. They're called the parameters for the regression equation. You round those to whatever the problem is asking for. Let me go back and look and see what the problem was asking to round to 2 decimal places as needed. So let me go back to what you're looking at. Where'd it go? Here, all right. So 2 decimal places. So when we type this into for our answer, it would be 99.78 x squared. The b would be 2.07, it's followed by a 3 times x. And then the c value, since the 7, the second decimal place is followed by an 8, that would bump the 7 after the 6 up to an 8. So the third statistic would be minus 1.68. Okay, that's just good enough to get it into my math lab to kind of verify that you did the procedure correctly. If I were going to use a model, I know that this particular problem didn't ask for it. Some of the word problems, the first thing you do is get this model, and then the second thing and third thing is you use it as an input-output function where we give you input values and you make a prediction, or we give you an output value and you have to kind of set up an equation to solve. So if I were going to turn this into a function that I can use to plug in different values, I'm just going to use x and y. Actually, instead of y, I'm going to use a function value. So instead of y, I'm going to call it f of x. And instead of the regression command, I'm going to say equals. I want to know all the points. And then I'm just going to use the a, b, and c instead of these specific values times the x squared and so on. So instead of typing, to start it off, 99.78 times x squared, I'm just going to say a times x squared. And Desmos has already computed the value for a into more accuracy than what the display says. And the rest of it, I'll just say bx plus c. Okay, so you'll notice this one graphed in black right on top of the green graph. That's because Desmos uses all of these decimal places when it's plotting that model. But we need something that we can plug values into. If we're asked in after this, okay, well, what's the profit for producing 50 units? You'd have to plug 50 into a function. So that's why I did this line 3. So if you're doing a word problem where they give you a data set from a particular representation of, x is years and y is dollars or whatever it is, put your data in, get the regression model using the x1s and y1s and that little regression tilde symbol. Once you have that, go ahead and write it up as a function. So write f of x, not x1, f of x equals, and then you'll type in the model equation using the ABC letters, variables for the coefficients instead of the specific numbers. And then you'll use like x squared and x for the x parts, not the x1. So the x1, y1 is when you're using data sets, and there's the regular letter x is what you use when you're writing a function. So for like part C then. So if you look at the third one I have here, that looks like a general form for a quadratic, but the calculator or Desmos has already figured out specific values for the A, B, and C. So I could plug in different numbers for this. I wanted to do, so we don't have a value in our table for 5. It skips from 4 to 6, so maybe you want to know what it is for 5. If I plug 5 into that model, it gives me 2,500 and something. And if you look at the table, that makes sense because 4 and 6 have outputs that are below and above 2,500. 2,500 is in here in this gap between 1602 and 3605. So it makes sense that the x value that goes with it was 5, which is between 4 and 6. So the number that came out is expected to be a number between the two that we see in the table. All right, that's probably more than you wanted to know, but I know that some of you are kind of struggling, especially to figure out how to round things or how accurate to get it. But that's how you do the regression. And this line 2 right here is the model that I want you to use when you're doing regression. You do y1 tilde, and then you type your expression for whatever type of regression you're doing. We're doing a quadratic regression here, but when you get to the x, write x1. And then as you finish it up, it'll give you the specific values for the coefficients that go along with those terms. So if we were doing a linear model, let me just show you a linear model. It might not look as good, but let's do y1 regression, and then I'll do ax1 plus b, or mx1. I'll change it to m so it looks like what we're used to dealing with. All right, so there's mx plus b. So if you look at the red line, it's also increasing and the points are increasing. So you can force any kind of a shape through a scatter plot, but we can see when we compare those two, the line, the only thing the line does that's kind of consistent with the scatter plot points is it is increasing as you go from left to right, but it doesn't really pick up the nuances of the curvature of the scatter plot. Whereas you can see by looking at it that the green curve much more closely, in fact, actually hits all of the points. Okay, and notice the r-squared value on the line, it's still okay. It's a 0.92, which means it kind of has the same trend. The points are kind of going in a curve and the line's just shooting straight, but they both kind of start and stop at similar places. So it's not a terrible way to estimate it, but the quadratic fits it much better. All right, I'll get this stopped so I can go ahead and get this recording up to all of you that need it.